Hello everyone and welcome back to another video. Today we're going to start the M3 surface area and volume of 3D objects outcome. Some of the key ideas that we're going to explore in this outcome include the surface area and volume of 3D objects such as cones, cylinders, prisms, pyramids, and spheres. So the first shape that we're going to discuss is a square-based pyramid. Now the name for a square-based pyramid comes from the base. In this case a square, so thus we call it a square-based pyramid. Two important details that we need to differentiate between for any type of pyramid in general is what we call the slant height of a pyramid, and another height called just the regular height, but we also call it the perpendicular height. Now there's going to be a slight difference between them, as we can see in the diagram over here. The slant height of a pyramid describes the height along the side of the pyramid, whereas on the other hand, the perpendicular height takes the height straight down from the apex, or the very tip of the pyramid at the top, right down to the very center of the pyramid. So that height, once again, is also known as a perpendicular height. So I'm going to go ahead and write that down here. So keeping this in mind, if you're given one of these heights and you need to find the other, you're going to need to use the Pythagorean theorem. One other key definition to remember is the lateral surface area, which refers to every part of the object except for the base. So if we were to take a look at the lateral surface area of a pyramid, we would look at the four triangular faces and we would not include this square base at the bottom. So typically some of the steps that I try to follow when we are looking for the surface area of a pyramid, and really just any other shape, we're going to first draw a net of the shape and then label each side appropriately. We're going to figure out which formulas we're going to need, and then we substitute in each of those values and then solve. So taking a look at our first example here, I'm going to go ahead and draw a net based off the diagram that's given here. So starting off with my base, I'm going to go ahead and draw a square and follow that up with four triangles, hopefully all the same size or roughly the same size. And then we're going to label this according to the diagram here. So we can see that each of the sides of my square base are going to be 14. So I can go ahead and do the same thing here. So I know that this side is going to be 14. Now this 25 that we're looking at is actually our slant height of the pyramid. So I'm going to go ahead and write that down so we don't forget. So down here, I'm going to write slant height, just so we don't forget. Now the question is, where do we put this 25 in our little net here? Well, this 25 is actually going to be this line that comes right down the middle from the very tip of each of the triangles down to the middle of each triangle. So I'm going to go ahead and redo that maybe in a little green. So this green dotted line is my 25. So what I can do from here is set up a formula based off of what we see in this diagram here. So my surface area, I can go and say, is equal to, and we see a couple different shapes here. We can see my red square, and then we're going to add 4 of, and let's call them green triangles. Now some of you guys will find that there are formulas for the surface area of a pyramid floating out there on the internet, but what I would like for you guys to do is to be able to come up with your own formula that works and that you understand. So starting off with my area of my square, let's go ahead and call it length times width, or we can even say side squared. So s squared plus 4 of my triangles. Now you might recall from junior high that the area of a triangle is base times height divided by 2. So I'm going to fill in everything that I know once I get to this point. So my side squared is really just 14 squared. And I'm going to go ahead and add 4 of these triangles. Now the thing to keep in mind here is that this base, is actually the bottom side of each triangle. And we know that the bottom side of each triangle is actually the 14. So I'm going to go ahead and do the 14 in red. And then we're going to take our height, which is really just multiplying by 25. And let me redo that so it doesn't look like I'm subtracting. So 14 times 25, and I'm going to divide that by 2. Now let's go ahead and simplify a little bit. 14 squared gives me 196. The inside of the bracket simplifies to 14 times 25, which is 350, and 350 divided by 2 gives me 175. So then we are left with 196. And when we take 4 times 175, that gives me 700. So my final surface area is 896 units squared. Here in question number 2, I'm going to start off again by drawing a net of my pyramid. I think eventually I'm going to learn how to draw a triangle properly. So we've got your square base here at the bottom and 4 somewhat equal triangles attached to each side. Now we're going to label each of these. So my length of each side of the base is going to be 16. So that corresponds to the 16 here. So this is going to be 16. And then if we're taking a look at the green, or rather this green line here, this perpendicular height is what we're looking at. So I'm going to go ahead and write that this is my perpendicular height actually. So perpendicular height. So that doesn't really do us much good, this perpendicular height. What we actually need is to find the slant height, which is going to be this guy right here. This is what we're missing. So if we're missing this, then we actually want to go ahead and use the Pythagorean theorem to help us figure out what that side is going to be. So if I go ahead and trace over my lines here, let's say I've got a, let's do this in purple actually, feeling kind of purplish. So I got that purple there. I've got my green that I'm just going to reinforce here, and maybe a blue at the bottom. So I'm going to redraw my triangle that is either the green, purple, and blue on the side. And then let's label each of the sides here. So this side that we're looking for, let's call that, in this case, let's call this X, just to be safe. The green side, as we know, is going to be that 24. And then the blue side, we need to try to figure out what this blue side is here. If we look at this length of the entire bottom side, we can see that the entire length is going to be 16. But we know that the perpendicular height comes down towards the middle of the pyramid, and then the blue line starts from the middle. So if it starts from the middle and goes until the end, we are actually only going halfway across that 16, meaning that this blue line actually has a length of 8 units. So from here, we can use the Pythagorean theorem, a squared plus b squared is equal to c squared. And whenever you have the sum of the two sides that are not the hypotenuse, then your sum here is going to represent that hypotenuse. So we've got 24 squared plus 8 squared is equal to x squared. So here we've got 24 squared, which is 576. So 24 times 24 is 576, plus 8 squared, which is 8 times 8, or 64. And that's going to give us x squared. So 576 plus 64 gives me 640, and that's equal to x squared. Now, because we don't want x squared, I need to actually square root both sides. So maybe I'll squeeze in this square root sign here. So once again, we've got that equal to x squared, and I'm going to square root the right-hand side along with the left-hand side, because what this does essentially is it helps me get rid of this 2, or that square. So we're left with the square root of 640 is equal to x. So what I'm going to do here is I'm actually going to go ahead and label this as my slant height, just so we don't forget. Now, some of you guys might be wondering, why am I keeping this as the square root of 640? Well, if you were to punch in the square root of 640, and maybe I'll do that real quickly on my own calculator, square root of 640 gives me about 25.298222128 and so on. Now trying to figure out where you're going to round that is a little bit tricky. Round too early and you're going to throw off your answer. Round too late and you're just stuck writing a whole bunch of decimals during your work. So keeping it as an exact value of square root of 640 and using that in your equation ensures that you don't have to worry about rounding or writing down all of the decimals. So going ahead with my formula from the previous problem. So we have the surface area of what really amounts to just the square plus your 4 triangles gives me 16 squared because we have 16 times 16. And then we're going to add my 4 triangles. So in this case, I've got base times height divided by 2. And I'm going to plug in the rest of my values here. 16 times 16 gives me 256. When I plug in my base, in this case, my base is 16. And I'm going to multiply this by the square root of 640. And then divide it by 2. So at this point, you could really just put this into your calculator and be done with it. But I'm going to show you guys how to simplify this a little bit more so it makes your lives a little bit easier working with your calculator. So typically during BEDMAS, we simplify what's inside your brackets first. So we have 16 times square root 640, which we can't really simplify, not yet at least, but I'm going to take a look at the 16 divided by 2. This is 16 divided by 2, which is just 8. So we can actually take that and simplify it so it looks something like this. Now again, you don't necessarily need to do this, but it helps you out when you're trying to enter in all these numbers into your calculator. Then we got 4 times 8, which is 32. So then I have 32 square root 640. So when you finally punch this into your calculator, you end up with 1065 point, and we've got 543 showing up here. If I were to round to the nearest hundredth, we'd get 0.54. So we can say that this is in units squared. So again, could we really have gone from this step straight to the end? Yes, absolutely. But just because I didn't want to have to deal with typing all of this in, I'd rather just type in the plus 32 square root 640. So one last thing that I want to point out just from us taking a look at a couple of examples here is that the slant height of a pyramid is going to be the height of the triangle. So we can see here that this 25, the slant height of the pyramid, ends up being the height of your individual triangles. So just make sure that you guys are keeping that in mind while you're making these calculations. The biggest mistake that I see from Math 10C students is that you try to use the perpendicular height, this guy right here, as the slant height. So just make sure that you try to avoid making that mistake, understand which height you are given in each problem. So just a little bit of quick review before we continue on in this outcome. I want to talk about solving for a variable. Typically, if we're trying to simplify something, we use something called BEDMAS. So brackets, exponents, division, multiplication, addition, and subtraction. If we're trying to isolate or solve or really just get some sort of variable by itself, we're actually going to use reverse BEDMAS. So we're going to go from the opposite direction. We're going to undo the addition and subtraction first, then undo the division and multiplication, and then finally exponents, and then the brackets. So taking a look at our first example here, we're trying to get the x by itself. So we have to choose if we're going to move the x's to the left side or to the right side. For us, it's going to be much easier to move it to the left side. So I'm going to subtract 3x from both sides, and I get 5x is equal to negative 15. And then I can divide both sides here by 5. Once I do that, I end up with x is equal to negative 3. I can always check my answer by plugging this negative 3 back into my equation and just making sure that the left-hand side is equal to my right-hand side. Now this next problem, I'm actually going to do 2 different ways. So this 9x is equal to 3x minus 5. Let's go ahead and do that. So we've got 9x is equal to 3 times x minus 5. And then I'm going to make a line down the middle, and I end up with 9x is equal to 3 times x minus 5. I'm going to do it what I call the long way, first of all. Some of you guys might just not consider it long. Some of you guys might consider it short. but I'm actually going to simplify this guy first. So I'm going to multiply, or rather distribute, that 3 to everything inside of the brackets. And that gives me 3x minus 15. And this turns into that first example where I just subtract 3x from both sides. And I end up with 6x is equal to negative 15. And now here, all I need to do is divide both sides by 6. And I get x is equal to negative 15 over 6. I can divide both the top and the bottom by 3. So this gives me negative 5 over 2 as my final answer. So that was the long way of doing things. I'm going to go ahead and do it the short way, where you have really one less step here. So we can see here that we are multiplying this 3 with everything inside of the brackets here. If I were to kind of rephrase this question I asked you, well, if I have 9x is equal to, let's say, 3y here, and I said we're trying to isolate for y, perhaps. We're trying to get the y by itself. In order to get rid of this 3, I would just divide both sides by 3. Well, we're trying to get this x minus 5 by itself, so it's inside of the bracket, so we can think of this as kind of one entity. So what that allows us to do is to actually just divide both sides here by 3. So I'm going to divide the right-hand side by 3 and the left-hand side by 3. So this leaves me with 3x is equal to x minus 5. So what this has done is actually get rid of the 3 up here because I've divided it with 3 down there. Once I've gone ahead and done that, I can subtract x from both sides. I'm left with 2x is equal to negative 5. And then I divide both sides by 2. So once again, you're really just shortening up one step here, which is not a really huge deal in the end, but just understanding that there's different ways of approaching the same problem is pretty important. So this next example here might throw some of you guys off because now we've suddenly introduced this pi here. Now, for those of you coming from junior high, where you might have referred to pi as just 3.14, we're going to kind of scrap that in high school. We're going to think of pi as its own kind of entity. I know some people have just described it as using it like another variable. We can think of it kind of like using a pack of Skittles. So there's a whole bunch of Skittles inside one package, but I don't want to have to deal with the individual Skittles. I really just want to toss that package back and forth between the left and the right hand side. So you'll see what I mean in a second here. So I'm trying to get the x by itself. So my first step is to subtract 8x from both sides. So I've got 2x minus pi is equal to negative 3. And now because I'm trying to get this x by itself, I want to get rid of this negative pi. Well, the way to get rid of the negative pi is to add pi to both sides. So that's kind of what I meant by tossing around that package of Skittles here. So we're just going to take this whole thing and I undo this minus pi by adding pi to both sides. So I'm left with 2x is equal to negative 3 plus pi. My final step here is to divide both sides by 2. And I'll end up with x is equal to negative 3 plus pi divided by 2. Last but not least, I'm going to try to solve for r in this problem here. So we're going to start off by thinking of this top part as just one kind of package up top, and it's all being divided by 3. So since it's all being divided by 3, in order to reverse that, I'm going to multiply by 3 on both sides. So I get rid of the 3's on the right hand side, and I'm left with 3b is equal to 4 pi r cubed. This next step, I'm taking a little bit of a shortcut here, but I'm trying to get rid of this 4 pi in the same step. Now to get rid of this 4 pi, I'm actually going to divide by 4 pi, but inside of brackets. So what I do to one side, I also do to the other side. Now some of you guys might decide to do this separately and divide everything by 4 first, and then divide it again by pi. That's perfectly fine, but we're trying to be as efficient as possible. Now the reason why I need to make sure I divide by 4 pi in brackets is if we think about 4 times pi. Well, pi we know is 3.14159, so on. So 4 times 3 point something gives us something a little bit over 12. So we're really just dividing by 12 here. If we don't put those brackets, what your calculator will interpret it as is we're going to take that 4 pi, divide it by 4 first, and then multiply your answer by pi, which is quite different. So now that we've gotten rid of that 4 pi, we're only left with the r cubed on the right hand side. So 3v over 4 pi is equal to r cubed. And let me go ahead and, oops, apparently I can't move that. So I'm going to go ahead and rewrite this here in the middle. So is equal to r cubed. My final step is to actually get rid of that cubed. So again, in junior high, you learned about square rooting things and the opposite of it, which is squaring. But in this case, we're taking a look at a cube root. And the only way to get rid of a cube root, or rather a cube, is to cube root it, which you'll learn a little bit later on in the course. So I'm going to cube root both sides. And this just leaves me with 3v over 4 pi in brackets. And then we're going to take the cube root of this behemoth here. So the cube root of 3v over 4 pi is equal to my radius. Keeping the examples from the previous page in mind, let's go ahead and start to work backwards. We're given a question where we have the surface area of a square-based pyramid is listed at 475 centimeters squared, and the length of the base is 10 centimeters. So we are being asked what the slant height is. So I'm going to go ahead and do my best impression of a Picasso here. Let's draw my square-based pyramid. And we've got something that looks kind of like this. So we can see that our base in this case is going to be 10 centimeters. So right there, each side there is going to be 10 centimeters. And then we're trying to find the slant height, which in this case is going to go from that apex all the way down to one side there. Once we finish this drawing, let's go ahead and write out our formula. So we know we're going to have surface area is equal to the area of our base. We have that square at the bottom. And then we're going to add 4 of my, in this case, green triangles. And we can replace that with our formula. So again, we can have side squared plus 4 times the base times height divided by 2. So what we're given in this question is the surface area. So I'm going to go ahead and replace my SA, or surface area, with 475. That's going to be equal to 10 squared plus, so a little shortcut that I'm going to do here is because we have a 4 multiplying into the BH and then I'm dividing by 2, I can actually just replace this with a 2 and get rid of the 2 down there. If that doesn't really make a lot of sense, don't worry, you can skip that step, but just to make things a little bit easier for ourselves, I'm going to go ahead and replace the 2 there. And our base, again, like I said, we have a base of 10. And what I'm trying to solve for is the h. So in an earlier example, I said that the slant height of my pyramid is the height of my triangle. So if we were to take one of these triangular faces and kind of just put it flat on the paper there, this is the h that we're looking for. We're not looking for the perpendicular height of this pyramid. So working backwards, we know we've got 475, and maybe we'll simplify that first. 100 plus 20h. And then we can actually work backwards now. We're going to subtract 100 from both sides. And we end up with 375 is equal to 20h. And then dividing both sides by 20 gives us a height of 18.75 centimeters. Oh, it doesn't look like an 18. So we've got 18.75 as our answer. As per usual, we can actually substitute in this slant height back into our formula here, along with the base length of 10, and we should get 475 as our answer. Now you can pause the video and try out this next problem on your own, and then unpause to check your work once you're finished. Along with square-based pyramids, sometimes you will also encounter triangular and rectangular-based pyramids. Sometimes we call these triangular-based pyramids tetrahedrons. One thing about rectangular-based pyramids is they will require you to find two different slant heights in order to calculate their surface areas. And we'll take a look at that after this first example. So here we have a triangular-based pyramid with a slant height of 18 and a base length of 8. I'm going to go ahead and just say right now that this bottom side, or these three bottom side lengths, we're just going to consider that an equilateral triangle. There's really no way to tell from the picture, so I apologize. But we're just going to consider this an equilateral triangle with a side length of 8. So from here, what we're going to see is we need to find the area of our base, and we're going to do that in just a second, along with our three. And we'll consider all three of these equal faces. So you've got this triangle here, and we've got three of them, in fact. So I'm going to go ahead and draw a kind of a pictogram of our formula. So I've got my red triangle on the bottom. And then in this case, I've got three of these green triangles. So taking a look at this red triangle, you'll notice that we don't actually have the height of this of that base. So if I go ahead and draw my red triangle on the bottom, we'll see that since it's an equilateral triangle, I'm going to label each of these as 8. But in order to find that dotted red line in the middle, what we're actually going to have to do is we're going to have to split it in half. So this left side here is the height that we're looking for. My hypotenuse is still 8, but this bottom side that used to be 8, since we cut it in half, we can now label this as 4. So from here, we're going to use Pythagorean theorem. A squared plus b squared is equal to c squared. In this case, we have h being my a plus 4 squared, and that's equal to my hypotenuse squared, which is 8 squared. So I've got h squared plus 16 is equal to 64. I'm going to subtract 16 from both sides. Pardon me while I skip a step there. I'm going to subtract 16 from both sides, and that leaves me with 48. Once I square root both sides here, I'll be left with h is equal to the square root of 48. So I'm going to use this as the height of this bottom triangle here. So now we can go ahead and work this into our formula. So I've got my base times height over 2 for my red triangle, plus 3 of these green triangles, base times height divided by 2. And we can now substitute everything that we know. So the base of my red triangle is, of course, 8. And maybe I'll do that in red. So I've got 8 times the square root of 48, which we found earlier. And I'm dividing that by 2. And I'm going to add plus 3 of whatever I have inside of these brackets. So for my green triangle, the base is actually still 8. And then I will multiply it by my height of this triangle. So if I were to lay this triangle out flat, the height of this triangle is 18, which is the slant height of the pyramid itself. So I've got 8 times 18 divided by 2. So here I'm going to do some simplifying. If you feel like you can just put this into your calculator, by all means, go ahead and I'm going to make this a little simpler for myself. So I've got 8 divided by 2 just gives me 4. So I've got 4 square root 48. And inside of my brackets, I've got, rather on the outside first, I have plus 3. And now inside the brackets, I have 8 times 18, which gives me 144. And 144 divided by 2 gives me 72. So I've got surface area is equal to 4 times the square root of 48 plus 216. Once I add everything together, I get the surface area is equal to 243.71 units squared if I round to the nearest hundredth. Before we start this problem, let's take a look at why exactly we have to consider 2 different slant heights for a rectangular base pyramid. Let's say I take a rectangular base pyramid with a really exaggerated length and a much shorter width than usual. And if I were to maybe carefully draw my pyramid like so, hopefully what we can see is if I were to drop a line straight down to the middle of this pyramid and maybe my slant height along this one side here, and if we were to consider how long this might look, this hypotenuse here, if we were to actually have a in this case, my green slant height and my red dotted line, and maybe we'll do a blue here. So it does look fairly long. Now, let's say we were to draw another slant height coming down the, front of the pyramid here, and then maybe a little bit of yellow. So that purple line, if we were to take this triangle here, that red dotted line again, and we were to turn it so that this purple side is on the right hand side. Oops, purple on this side, and then the yellow along the bottom. You can already see that this blue length is much longer than this yellow length anyways, meaning that the green hypotenuse is going to end up being longer than the purple one. So that's with a really exaggerated base of a rectangle. Now, applying the same idea to our example here, I'm going to go ahead and draw my 2 different slant heights. So I've got this green one coming down the side, and then let's say we have a purple one coming down the front of this side. I'm going to go and connect these guys with the blue. And so from here, we can establish our surface area formula with some pictures. So the surface area of this guy is going to be my rectangular base plus 2 of my green triangles, so the ones with the green slant height, plus 2 of the ones with the purple slant height. And let's do that in black. So from here, let's go ahead and draw our triangles on the side. And maybe what I'll do before that is I will give the green line a value of x and the purple one a value of y. And then we can flatten these out into a 2D triangle. So let's start off with this red and green triangle. So I've got that red height there and the red across the bottom. And then let's label the x there as my green side. This 8 has to go along that vertical leg. And then across the bottom, if we're looking at it starting from the middle, going out to the right, this entire length would be 6. So that means that this red line would actually be half of this 6, meaning that it would be 3. From here, we're going to use Pythagorean theorem. We've got a squared plus b squared is equal to c squared. So I've got 8 squared plus 3 squared is equal to my hypotenuse squared, in this case x squared. So 64 plus 9 is equal to x squared. Adding them up, 73 is equal to x squared. And then I can square root the left-hand side and the right-hand side, leaving me with a slant height of the square root of 73. So I'm going to go ahead and box that in green to let us know that we've solved that one. And I'm going to shrink all of this and put it to the side for now. Looking now towards my purple, blue, and red triangle. So I'm going to draw this coming out towards the left. Got my purple side, and I'm going to label that Y. Got the red side, and that's labeled as 8. And now this blue side, so that's this line coming out here. Since we know that this entire length would be 4, and if we're starting off this blue line here in the middle, then this blue line would only have a length of 2. Once again, using Pythagorean theorem, a squared plus b squared is equal to c squared. We can fill it in with all of our values. 8 squared plus 2 squared is equal to y squared. 64 plus 4 is equal to y squared. 68 is equal to y squared. So square rooting both sides, I get the square root of 68 is equal to y, and I can go ahead and box this in purple. And we're going to put this off to the side while we work with the rest of our question. So taking a look at our original formula, I can actually go ahead and substitute in my numerical formula now. So I've got my base, which is my length times my width, plus 2 of my green triangles. So I've got 2 times your base times height divided by 2, plus 2 of my purple triangles. So again, base times height divided by 2. So once again, we can have a bit of a shortcut here. We can get rid of the 2's, because if I multiply the 2 into here and then divide by 2, really I'm just getting an answer of 1. So I can get rid of the 2's out here and the 2 on the inside. So I get my surface area is equal to the length and the width of my rectangle. So I've got 6 times 4. So I can do that in brackets, 6 times 4 plus, in this case, my green triangle. So we're looking at this guy here. My base is 4 times my height. So we found out the height of this guy, or rather the slant height of the pyramid, the height of my green triangle was the square root of 73. And we are going to add that to the base of my purple triangle. So my purple triangle here has a base of 6. And we're going to multiply that with the square root of 68, which in this case, the square root of 68 is the height of this purple triangle. So once I pop this all into my calculator, I end up getting an answer of 107.65. This would be units squared if I round to the nearest hundredth. So moving on to our next shape, which are the cones. You guys might notice that if we actually kept increasing the number of sides that a pyramid has, we actually end up with a cone. So we can see from our diagram here that a cone has 2 shapes. First of all, this circle at the bottom, and this, what I like to call a pizza wedge. We can then look at our formula and see that this pi r squared is really just the area of our circle. So you guys have talked about the area of circles back in junior high. So this guy here is represented by pi r squared, which means that this guy, that pizza wedge, is pi rs. So you might guess that the S stands for slant height, so you'd be absolutely correct. So we can go ahead and label that S as our slant height. So taking a look at our first example, all we're going to do is start by writing down our formula. So we've got surface area is equal to pi r squared plus pi rs. And then we're going to identify our known variables. So in this case, we can see here that our radius from the middle of the circle to any of the outside edges, we got a radius of 7. And then we're looking for our slant height. So in this case, our slant height is 18. So it's going to be this guy right along the side. So it's really just a matter of us plugging these numbers into our formula. So pi times 7 squared plus pi times 7 times 18. So at this point, if you would like to plug this into your calculator, that would be perfectly fine. But as you guys might already guess, I like to simplify things a little bit more before I reach for my calculator. So I've got 7 squared here, which is 49, so 49 pi. And then I have my 7 times 18, which is 126. So 126 pi is what I have. I'm going to add together my two coefficients. So I got 49 plus 126 gives me 175 pi. If you're confused about why I'm allowed to do that, think about this as 49x plus 126x. I would just simply have 175x. So we're just going to treat pi almost the same as a variable in this case. So once I go ahead and pop this into my calculator, I get a final answer of 549.78 units squared if I round to the nearest hundredth. In the second example, once again, we're going to start off with our surface area formula. So pi r squared plus pi rs. And let's identify our known variables. So in this case, our radius is 5.7 centimeters. But we run into a problem when we notice that we don't actually have a slant height here. So we're looking for this guy right along the side. So I have no idea what that is just yet. But we do have a couple tricks up our sleeve. So let's go ahead and label that as S. And by now, you'll probably know that we need to use the Pythagorean theorem to help us figure out that slant height. So if I label the 12 here and the 5.7 along the bottom, we can go ahead and start using our Pythagorean theorem. A squared plus b squared is equal to c squared. So I've got 12 squared plus 5.7 squared is equal to s squared. So 12 squared, 12 times 12 gives me 144. And then 5.7 squared gives me 32.49. That's going to be equal to s squared. If I add these two guys together, I get 176.49 is equal to s squared. And then I take the square root of both sides. So 176.49 is equal to my slant height. And now that I found the slant height, we can go ahead and plug in our known values. So pi times 5.7 squared plus pi times 5.7 times the square root of 176.49. So plugging all of this into my calculator gives me a final answer of 340 centimeters squared when rounded to the nearest whole number. Now for this next question, we're going to once again be working backwards. So I'm going to draw a diagram to help us get started. So I've got my cone here and we are given a surface area of 525. So I'm going to go ahead and label that. And then we are given a radius of 8 centimeters. So that 8 centimeters is going to go right there. So r is equal to 8. We are looking then for the slant heights. We're looking for this guy along the side. So s is equal to a question mark in this case. So we've got our formula here. Surface area is equal to pi r squared plus pi rs. I'm going to go ahead and plug in everything that I know. So 525 is equal to pi times 8 squared plus pi times 8 times s. Simplifying a little bit leaves me with 525 is equal to 64 pi because 8 squared is 64 and 64 times pi gives me 64 pi. And cleaning this up a little bit, or reorganizing, or rather reordering how this is written, I'm going to write this as 8 pi s. Now for those of you who are wondering whether or not it matters if I put the pi first or the 8 first, mathematics also follows a very similar writing convention as the English language does. So for example, if I said, hey, look at that big red truck drive down the road, none of you would really bat an eye. But if all of a sudden I said, hey, look at that red big truck drive down the road, a lot of you guys would look at me and say, that just sounds a little funny. And that would be the same case for this. We would rarely see pi 8s written in mathematics. Typically we have our numerical coefficient come first, then any known constants such as pi, then finally followed by any of our variables towards the end. So from here, I'm going to get rid of my 64 pi from both sides, and I'll do that in red. And that's because our goal is to get rid, or rather isolate, this S. So I'm going to get rid of everything around it. We can think of this S as the last layer of the onion that we want. So this outer layer is what we want to peel off first. So I'm going to subtract 64 pi from both sides. And I'm left with 525 minus 64 pi is equal to 8 pi S. Here I can divide both sides by 8 pi in brackets. And then I'll do the same on the left-hand side. Once I've done that on this side, I've got 525 minus 64 pi divided by 8 pi in brackets is equal to S. So once I pop that into my calculator, I get a final answer of S is equal to 12.9 centimeters. So our next section here deals with spheres and hemispheres. So our formula for a complete sphere, kind of like an orange or a soccer ball, is just 4 pi r squared. So we can imply from the pi r squared is we're looking at one circle, but instead of just one, because of that 4, we're actually looking at visually 4 circles is what you can think of covering the outside of the sphere. Now we want to keep that in mind as we cut the sphere in half into our hemisphere. If we were to start off with 4 circles and we cut it in half, naturally we'd think that there are only 2 circles left, and you are absolutely correct. But if we were to have our visual of an orange and we cut that in half, we still have the 2 circles on the outside where the peel is, but on the flat side that we've now cut into, there's another circle up on top of that orange. So we'd have the 2 circles plus that extra circle on top, leaving us with a formula of 3 pi r squared. So again, just to take a look at the difference, a sphere is 4 pi r squared versus a hemisphere that has a formula of 3 pi r squared. So using our surface area formula, we can go ahead and solve the surface area of each of these spheres at the bottom. So in this first case, we have r is equal to 6 meters. So instead of having r, we're just going to put a 6 in there. And we have the surface area is equal to 36 times 4. So in this case, 36 times 4 is equal to 144. So we have 144 pi. And when I plug that into my calculator, I end up with 452.4 meters squared if I round to the nearest hundredth. For the second example, we'll notice that our diameter is given in this case, but we want the radius to work with the formula. So r is equal to d divided by 2. So 18 divided by 2 gives us 9. So with our formula, 4 pi r squared, we have 4 times pi times 9 squared. So 9 squared gives me 81. 81 times 4 gives me 324, so 324 pi. And I get a final answer of 1017.9 meters squared when rounded to the nearest tenth rather. Taking a look at this third problem, we have a hemisphere now. So we see that we have a radius of 6 centimeters. So we start off with our formula of 3 pi r squared. So instead of having this 4 there, we just have a 3. And then instead of having an r, we have a 6. So 6 squared is 36. 36 times 3 gives me 108 times pi. And 108 pi gives me 339.3 centimeters squared when rounded to the nearest tenth. So here's another question where we have to work backwards. We're given the surface area and we need to find the radius. So starting off with our formula, surface area is equal to 4 pi r squared. We're going to plug in everything that we know. So surface area is 525, and that equals to 4 times pi times r squared. So once again, to solve for this r, I'm going to try to peel back the layers of this so-called onion. That means I need to get rid of this 4 pi. So I'm going to divide both sides by 4 pi in brackets. And this leaves me with 525, and maybe I'll do that in black. So 525 divided by 4 pi is equal to r squared. So what I need to do to get that r squared by itself is just to square root both sides. So I can square root both sides and I end up with the square root of 525 divided by 4 pi is equal to r. And if I put this carefully into my calculator, I will get a final answer of 6.5 centimeters squared when rounded to the nearest tenth. If you don't get 6.5 centimeters squared, that means that you have inputted this incorrectly into your calculator. I would probably guess that you took 525 divided by 4 and you put the pi right afterwards without putting these in brackets. If you do that, you're going to get a little bit of a larger answer compared to the 6.5. So make sure that you are inputting this exactly as you see here. I would start with the 525 divided by the 4 pi in brackets. Once you get that answer, square root whatever you had as your answer there, and you should get 6.5 centimeters. Here you can pause the video and try this next problem on your own, then unpause once you're done to check your work. So for this last section of surface area, we're going to talk about composite shapes, which are just shapes that are made up of more than one object. We're going to be working with the same formulas, except we're going to get rid of any of the faces that we actually don't see. So in order to do that, we're going to do a few key things. First of all, we need to come up with a starting formula from which we're going to subtract all of our unnecessary portions. So looking at our first composite shape here, we have a cone plus a cylinder. So our total surface area is going to be some combination of the surface area of our cone plus the surface area of our cylinder. So writing down our mathematical formulas for each of these, and I'll do these in different colors. Our surface area of the cone will be pi r squared plus pi rs. And then for the cylinder, we have 2 pi r squared plus 2 pi rh. So now that we have our formula ready, let's try to figure out which portions we can actually cut out. Starting off with our cone here, we notice that the circular base is actually covered up because it's on top of the cylinder. So what I can do is subtract, or just cancel that out. I don't need that pi r squared, since that pi r squared represents the circle at the bottom of my cone. So that means we're just looking at this lateral surface area, or that pizza shaped wedge. If we were to draw this net of our cone, we don't see the circle here, so I can actually just get rid of that. Looking at our cylinder, and if I were to draw a quick little net here, we don't see one of the circles. We don't see the one here at the top because the cone is sitting on top of it. So we have to get rid of one of these circles. And the circle that we're going to get rid of, doesn't really matter which one because we can't really tell the difference in the formula. But because we know that we have 2 pi r squared, so we have 2 circles, I'm just going to get rid of that 2. And now we are just left with pi r squared. This 2 pi r h represents that side that wraps around the outside of the cylinder. So again, if I were to draw this and we just got rid of this circle on top, this 2 pi r h would represent that rectangle there in the middle. So cleaning up our formula here, we're just left with, and maybe I'll do this in red, we're left with pi rs plus our pi r squared from the bottom of the cylinder plus your 2 pi rh. Now, typically, if we're looking at some sort of object that is not a contextual problem, we will usually just count the bottom of your base. So just to make sure that you verify with your teacher. So a contextual problem might sound something like you're trying to paint a house that is sitting on the ground. Obviously, you're not going to paint underneath the house, so we don't need to consider the surface area underneath the house, just everything on the outside. So looking at our formula here, let's go ahead and identify what we know and what we don't know. So the radius will stay the same for both the cone and the cylinder. So in this case, radius is equal to 5 in this case. Your height from your cylinder is equal to 10. So we're just going to make sure, and maybe I'll highlight that just to emphasize that. So your height that we're looking for is this guy here, that height from the cylinder. And then going back to our slant height, we're looking for this guy. So for the interest of time, I will quickly tell you guys that this slant height is actually equal to the square root of 41. So you can go ahead and try that out on your own time, but just to save myself a bit of time here, I'll tell you guys right away. So I'm just going to plug all of my numbers into my formula. So I've got pi times 5 times the square root of 41 plus pi times 5 squared plus 2 times pi times 5 times 10. And because I love simplifying so much, I'm going to go ahead and simplify this just a little bit. So I've got 5 times the square root of 41. And let me clean that up a little bit actually. So 5 times the square root of 41 plus 5 squared gives me 25 pi. Then I've got 2 times 5 is 10 times 10 gives me 100 pi. So really I've got this 5 times the square root of 41. Oops, I forgot the pi up here earlier. My apologies. Times pi plus, and I'm gonna have plus 125 pi here. So when I finally plug this all into my calculator, I end up with a grand total of 493.3 centimeters squared. So some of you might be wondering if this is the only way to do this problem. No, there's actually another way. What some teachers might teach you is to just find the surface area of the cone, add it to the surface area of the cylinder, and then subtract everything afterwards. Personally, I like to get rid of everything at the beginning because one, you're getting rid of unnecessary steps, and two, what I've found with students who like to subtract things afterwards is that they tend to forget to subtract them. So doing this early on kind of mitigates that issue, at least in my opinion. So again, there's more than one way to solve this, but this is typically the approach that I start with. So looking at this next example, starting off with a rough idea of what we want to find, is we're looking for the surface area of a cone plus the surface area of a hemisphere. So our total surface area, once we actually put in our formulas, we have pi r squared plus pi rs for the cone. And then we're going to add 3 pi r squared for our hemisphere. So once again, we need to ask ourselves, what are we actually getting rid of from our formula? Well, for the cone, we can see that we, again, don't see the bottom of the cone. So I'm going to get rid of the pi r squared here. And that represents that circle that I just shaded in. And then that pi rs we still see, so we're just going to leave that in there. And then for the hemisphere, we don't see the top, that flat circle that's sitting on top there. So we know that for a hemisphere, we can think of it as 3 circles. But since we're getting rid of 1 circle, instead of having a 3, I'm just going to replace that with a 2. So our total surface area is just equal to pi r squared, or rather, let me do that in red. So not pi r squared, pi r s plus, instead of the 3 pi r squared, we now have 2 pi r squared. So now we can go ahead and identify all of our variables. So in this case, our radius is equal to 4. And once again, in the interest of time, I will tell you guys what the slant height is. So this guy right here is what we're looking for. That's my slant height. So in this case, my slant height actually happens to be the square root of 116. And you can also verify that on a separate sheet of paper. So now all we need to do is plug in all of our variables. So pi times 4 times the square root of 116 plus 2 times pi times 4 squared. So plugging this all into your calculator, we end up with a grand total of 235.9 centimeters squared. So here you can pause the video and try the workout on your own. Again, for the interest of time, I'm not going to solve and show every single step. Rather, I'm just going to be highlighting some of the main points behind each of these. So feel free to try to work through these on your own. And if you have any specific questions about any of the steps I've taken here, feel free to leave those questions in the comment down below. So moving on to the volume of the exact same shapes that we just covered, starting off with the volume of pyramids, we have our formula. Volume is equal to 1/3 of the area of your base times the height of your pyramid. Alternatively, we could also write the formula like this, and I personally like this a little bit more. Volume is equal to the area of the base times your height, and all of that is divided by 3. So mathematically, they're all the same, but I find that this is a little bit easier for most students to follow along, because we won't run into the problem of, well, what happens to the 1/3? How do I get 1/3 in my calculator? Just find your area of your base times your height, and then just divide your answer by 3. Now, how did this formula come to be is a question we might ask. We're going to take a look at this picture here, where we have our rectangular prism. So we could call this the height. We can call this the width, and this can be the length. So and maybe what I should actually do is, let's go ahead and put these guys up here. So I've got my length and my width here. What we're going to notice about this is I can actually put an equal sign there. And what this is representing is if I have 3 pyramids with the same length and the same width, so this guy right here, so the same width, so same length and same width, and the same height. So the height, if I were to draw a perpendicular line from the middle of each of the pyramids, that height would also be exactly the same as the height of my rectangular prism. So what we're saying here is that if we were to take the volume of the rectangular prism and just divide it by 3, we would get 1 of my pyramids. But it would take 3 of these guys to fill up the volume of one rectangular prism, given that their length and width of their bases are the same, and the height of the prism and each pyramid is also the same. So starting off with question number 1, I'm going to go ahead and use the formula that I had set up. Volume is equal to the area of your base times your height divided by 3. So since we are working with a square base pyramid, we know that the area of your base has to be 16 times 16. So we've got volume is equal to 16 squared times your height in this case, which is 24. And then we're just going to divide that answer by 3. Once I pop that into my calculator, I get an answer of 2,048 units cubed, or you can say cubic units. This next one here, once again, starting off with our basic formula, area of the base times height divided by 3. Our area of our base is pretty straightforward. It's just going to be 14 squared because we are looking at a square. The only other problem is our height. We don't actually have the height of our pyramid here. That's going to be this guy in the red. So we're missing that height. So what we're actually going to do is we just need to use Pythagorean theorem as per usual. And I'm just going to do that here on the side. So I've got my blue portions And then I've got the red one, which we'll call h. I know that this is my slant height of 25. This bottom side, because I know that the full length is 14, then this from the middle to the end has to be 7. So using Pythagorean theorem, I know I've got a squared plus b squared is equal to c squared. So my hypotenuse in this case is 25, so I know it has to be equal to 25 squared. So I've got h squared plus 7 squared is equal to 25 squared. I've got h squared plus 49 is equal to 625. If I subtract 49 from both sides, so I've got h squared is equal to 576. So once I take the square root of both sides, I get h is equal to the square root of 576. So let's plug this into my formula, 14 squared times the square root of 576, and we're dividing that by 3. So when I plug this into my calculator, I ended up getting an answer of 1,568 units cubed. So moving on to the volume of cones, we have our formula, volume is equal to pi r squared h divided by 3. So if you might recall from earlier grades, we've actually talked about this top portion, this pi r squared times h. This is actually the volume of a cylinder. So your volume of a cylinder is equal to pi r squared h. So where does this divided by 3 come from? Well, we can actually look to this picture to give us a bit of an answer. Since we know that the volume of a cylinder is just pi r squared h, so I'm going to go ahead and write that here, pi r squared h, and we can see that one of these guys, or one of the cones, is pi r squared h divided by 3. We can say that the relationship is that your cone is 1/3 of the volume of a cylinder. So if we were to look at this from the other dimension, we could say that 3 cones makes up the volume of 1 cylinder. Now there's a couple of conditions that need to be met in order for us to claim that's true. If we're looking at the circular base at the top of each one of these shapes, so we can go ahead and highlight that there. So each one of those circles, they need to have exactly the same radius. So this radius has to be the same as this radius, has to be the same as this radius, and this radius for this to work. And the second thing that has to be the same is for the height. So the height of the cylinder has to be the same height of each of these cones. So again, this cylinder, if it has the same radius and the same height as these cones, has a special relationship. 3 of these cones will fill up 1 cylinder. If I divide the volume of the cylinder by 3, then I end up with 1 cone. So that's the relationship between cylinders and cones. One additional thing to keep in mind is that the h here represents the perpendicular height of the cone, not the slant height, as we covered back with surface area. So starting off with example 1, I'm going to go ahead and write my formula. Volume is equal to pi r squared h divided by 3. I'm going to identify my radius as 5.7 centimeters and my height as 12 centimeters. I can go ahead and plug in all of my values here. Pi times 5.7 squared times 12, and all of that's divided by 3. So one thing to keep in mind is to not forget to divide by 3. That's another common mistake I see by students. And once I plug this all in, I get an answer of 408 centimeters cubed. For this next problem, let's go ahead and start with our formula. Volume is equal to pi r squared h divided by 3. I noticed that my radius here is 7, but I am missing my slant height, or rather my perpendicular height, which is going to be this guy here. So I actually have to use, as you might guess, Pythagorean theorem. So let's go ahead and draw our triangle here, and really we're just looking at this guy, this triangle, the black and the red. So we know that the red is what we're looking for, that's our height. We know that the slant height, that's what this is, that's 18. And then here at the bottom, our radius is 7. So I don't need to divide this in half. So please make sure that you're aware of that. If it's already the radius, we don't need to divide it in half. So for the interest of time, as we're sitting at about probably close to, it feels like 2 hours into this video at this point, I'm just going to go ahead and give you guys the height of this triangle, and that ends up being the square root of 275. So I'm going to go ahead and plug that into my formula. Volume is equal to pi times 7 squared times the square root of 275. And I'm going to divide that all by 3. And I get a volume of 850.9 units cubed. So taking a look at the volume of spheres and hemispheres, we have our two formulas here. For a sphere, it's just 4 pi r cubed. So please make sure you take note of that. 4 pi r cubed divided by 3. And then for the hemisphere, since we're just cutting it in half, we're literally cutting it in half. Instead of a 4, we just have a 2. So 2 pi r cubed divided by 3. Now, of course, at any time, if you do forget the formula for a hemisphere, you can just pretend you have a full sphere and then just divide your final answer by 2. So starting off with this example, we've got a radius of 6. So our formula, I'm just gonna assume we've written our formula down already. So we've got 4 pi times 6 cubed divided by 3. And we get a volume of 904.8 meters cubed once you plug that into our calculators. Same thing for the guy here on the right. We're working with a hemisphere, so our formula 2 pi r cubed over 3. We have 2 pi times 6 cubed over 3. And once you plug that into our calculator, we end up getting 452.4, and this will be in centimeters cubed. Down here, we need to take note that our diameter is 18. So we need to divide that by 2 to give us a radius of 9. So volume is equal to 4 pi r cubed over 3. I just have to give you guys a reminder that it's cubed, not squared. Once again, another very common mistake that I see students making is they put a squared here. So we get 4 pi times 9 cubed over 3. And we get 305. Or sorry, not 305, we get 3,053.6 meters cubed. So for this question on the bottom right, I'm gonna go ahead and start with my formula, 4 pi r cubed over 3. And we need to substitute in all of our known values. So in this case, our 770 is our volume. So 770 is equal to 4 pi r cubed over 3. So our first step is to multiply both sides here by 3. And we end up getting 2,310 is equal to 4 pi r cubed. Our next step is to divide both sides by 4 pi in brackets. And we'll end up with 2,310 over 4 pi is equal to r cubed. So if you remember from way back in the video, it feels like ages now, we actually did this problem. We have to now cube root both sides. So cube root the left and the right side. And we are finally left with the cube root of 2,310 over 4 pi. And that gives us the radius. So assuming we have then put it into our calculator correctly, we will end up with a radius of 5.7 centimeters. So this will be a little bit tricky to pop into your calculator. What I would do first is I would do the 2310 and then divide it by 4 pi in brackets. So basically you're doing 2310 divided by about 12-ish, 12 point something. And then whatever answer you get, you're going to cube root it to get 5.7 centimeters. So here we're going to have a little bit of practice working backwards on each of these problems. So feel free to pause the video here and then unpause once you are done to check your work. Our final section of this outcome talks about finding the volume of composite shapes. Now, earlier on, you might have a little bit of trauma from looking at the surface area of composite shapes, but I assure you this is objectively a lot simpler. All we need to do is identify each volume of each shape and then just simply add it up. There is no need to subtract anything. So jumping right into example number 1, we have the total volume is equal to the volume of a cone plus the volume of a cylinder. So in this case, we have the volume is equal, we're looking at the cone, we have pi r squared h divided by 3. And then we're going to add that to the volume of a cylinder, which in this case is pi r squared h. Now, the only tricky part about finding the volume of these is keeping in mind that the height of certain objects are going to be a little bit different. So in this case, the height of the cone rather is going to be 4 centimeters, and then the height of the cylinder is 10 centimeters. So those are the things that we need to keep in mind as we are working through this. So your volume is equal to pi times your radius. So the radius for both is going to be, maybe I'll write that down, radius is equal to 5 centimeters. So pi times 5 squared times the 4 centimeters that we mentioned earlier, and that's divided by 3. And we got plus your pi times 5 squared, again, same radius, except your height here is going to be 10. From here, we just need to plug that into the calculator and we get a grand total of 890.1 centimeters cubed. For example number 2, we just need to identify that our total volume is equal to the volume of a cone plus the volume of a hemisphere. So starting off with the volume of a cone, we once again have pi r squared h over 3. And we're going to add that to the volume of our hemisphere. Oops, still thinking about surface area. Plus 2 pi r cubed over 3. So there's nothing too crazy about this one. We only have one height and our radius is the same for both. So we have pi times, in this case, we have 4 squared times the height, which is 10. And that's divided by 3. We have plus 2 pi, and the radius again is the same. 2 pi r cubed over 3. And once we plug this into our calculators, we get 301.6, oops, not meters, we've got 301.6 centimeters cubed. This third example here, we have 3 different shapes. So we just have the volume of a hemisphere, plus the volume of a cylinder, plus the volume of a cone. And we're just going to write them all out. So we got the volume of a hemisphere, 2 pi r cubed over 3, plus our volume of a cylinder, which is pi r squared h, plus the volume of a cone, pi r squared h, divided by 3. And again, the only tricky part about this that I can potentially see coming up is we've got the height of your cylinder. It's going to be this guy. And then we've got your height of your cylinder, or not your cylinder, your cone rather, is going to be this guy. So just make sure that you are aware that h is going to be different for each of those. So you got 2 pi times 4 cubed over 3 plus your pi times your radius, which is 4 squared, times your height, which is going to be this 10 here. And then we're going to add that to your cone, pi times 4 squared. And maybe I will actually move that down here so we can see it. Pi times 4 squared times your height, which is 3. And then once we enter that all into your calculator, we get 580, I'll make that a little bit neater, 586 meters squared. Last but not least, we've got two shapes actually from earlier grades here. We've got the volume of a triangular prism, tri-pi I guess, and plus the volume of your rectangular prism. So let's go ahead and write our formulas down. So the formula for the volume of a triangular prism is really just the area of your base times your height. And then for your rectangular prism, it's just length times width times height, so nothing too crazy. So the only potential tricky part about this is remembering that the area of your base of your triangular prism is going to be that triangle. So the area of a triangle is just base times height divided by 2. And now we're going to multiply that by the height, or really the length in this case, which is going to be the 5 centimeters. So just make sure you're keeping that in mind as we work through this question. So that would be, in this case, well, I'll keep it as h for now, and then plus your length times width times height for your rectangular prism. So let's go ahead and substitute these in. Base times height, the base of your triangle is 8, the height is 4, divided by 2. I'm multiplying that answer by 5. And now I'm going to add my length times width times height. So 8 times 5 times 6. And once I do all of that legwork on my calculator, I get 320 centimeters cubed. So I hope you guys learned a thing or two about the surface area and volume of 3D objects. Thanks again for watching, and I'll see you in the next video.